graphing it. All right? So now I'm going to actually ask you to graph the line. All right? And so how that starts is me giving you an equation that looks like this. And everything we've learned up to this point goes back to that horrible table of values that you have to create every single time, because I haven't taught you the official, shortcut way yet. So now it doesn't say anything about make sure your domain is 2, 3, 4, 5, 6. Anything goes. You pick whatever you want. -1, 0, 1 is enough. Some people like to get fancy and they like to do 5 points. If you want to do these 3, that will give you a good enough idea. Now, let me just show you how annoying this can get. So you could say, I'm going to take -2, multiply it by the x, add the y, and get -3. In this case, I'm not plugging both in. I only know the x, as opposed to the other example. I'm looking for the y. So when I put -2 right here, that's my input, +4 plus y equals -3. It's like a mini equation that I have to solve. So my y value is going to be -7 when my x value is 2. That was not quick, because now guess what? It's not solved for y, so I got to do that again for 1 and 0 and 1 and 2. I'm not going to do that 5 times. I don't even want to do it 3 times. So are we always looking for ways to save time? Yes, I'm going to show it to you right now. When we did this example, and when y is by itself, okay? So here's what I want you to put. Save some time. Get y alone. And this is what, oh man, this is a skill that you're going to need for every single standard we do for the next 2 months. And if you don't learn it now, it's going to haunt you. So learn this now. Learn how to solve for y. So if I start with my original 2x plus y equals -3, and just think about it. So I want to get y by itself. What's being added to y? A -2x. So how do I get rid of adding or subtracting 2x? I add it. So I'm going to add 2x here. I'm going to add 2x here. Now, stop here for a second. Actually, just do this. Because I canceled it here. I got y by itself, but I have a little bit of a mess over here. Let's kind of do a little sidebar and talk about what would happen if that x wasn't there. What would you do with this +2? Wouldn't you just combine like terms? Because -3 and 2 are like terms. They're both constants, right? Are -3 and 2x like terms, though? No, I can't combine that and make that -1x. I can't combine it at all. So what do you do then? You write them both, right? So you have to decide, do you want to write it as the -3 and then the 2x? Or do you like the other way with like the x first? Okay, so you might say, it bothers me. I like it when the x is first, kind of like when we did our word problems, right? Okay, yeah, no, that's a -3. So you got to watch that. That 3 is negative, that 2 is positive. So the middle sign belongs to that. So either one is acceptable. However, 90% of the time, you'll see it in this form right here. Okay? So getting y alone is a must in algebra. And guess what? There's a fancy way to say that. Does anybody know the name of this form right here? This is called slope intercept form. And we're not even gonna get into the specifics of it yet, but I know you probably heard that y equals mx plus b a little bit last year, right? Okay. So solve for y means put it in or slope intercept. That's a fancy way of saying it. All right, so not all of them are going to be that easy. How about 12x minus 3y equals 15? This one's a little different because up here, there was no coefficient in front of y. But now there's a -3. It's a little bit of a game changer. So look here. First thing you want to do is cancel out your x term. You with me? Divide negative 3y is equal to, make your decision. You're going to go one order or the other. I always like to stick with this, then put my constant. If that negative 3 coefficient wasn't there, I would be done. But it is there, and it's being multiplied. So what's the opposite of multiplying? Division. Now, there's no question about what I do here, but do you remember doing this in bell work a couple times? What did I say you're supposed to do? This is an expression. You have to divide the whole expression, meaning everything in that expression by negative 3. Not just the 15, not just the negative 12, but both. That's going to leave me with y equals here, and you got a little cleaning up to do. What's a negative 12x divided by a negative 3? It's a positive 4x, right? What is a positive 15 divided by a negative 3? Negative, and look how I write it. Looks like a minus. It's negative 5. So look what I just did. I took this equation with a 12, a negative 3, and a 15, and I turned it into 4x minus 5. You would never think that those were the same two lines, right? So if I were to one day give one kid this equation, ask them to make a table of values, and give another kid this equation, ask them to make a table of values, and they both graphed it, they would be like, wait, your line's the same as mine. I know, because it's the same line with two different names. It's like asking somebody to plot 1/2 on a number line, but asking somebody else to plot 5/10. It's the same point, just in two different forms. So guess what? I gave you the name of this form. Why don't I give you the name of this form too? This is called standard form. It's going to pop up again later. All right, standard form. I'm going to show you one more example, and then we're going to talk about why this is so crazy useful. So the next example that we're going to do is not so pretty. And everything ain't unicorns and rainbows in algebra, right? There are real answers that are not whole numbers. So, what do I want to do first? It's in standard form. Put it in slope-intercept form. Get rid of your x term first. That leaves you with negative 5y is equal to negative 2x and a positive 12. My last step is to divide what? Everything by negative 5. All three pieces. That's going to give me some ugly looking fractions. So, 2/5. Don't overthink it. It's not improper. You don't make it a mixed number. Cancel the negatives, and you're done there. This one, a positive divided by a negative is a negative. And remember, it's algebra. You don't have to show me a mixed number. You could leave it like that. You could tell me the answer is 2/5 x. Notice I put the x in the middle. Minus 2.4. You could tell me y is equal to 2/5 x minus 2 and 2/5. I don't care. They're all the same to me. Yes?
Could you do like y equals 4 times?
Yes. Yeah, so you could, well, you absolutely could, but we're going to learn later that when we talk about slope as rise over run and you start to graph these, graphing 0.4 is not as easy as going up 2 and over 5. So for the first time in your life, you actually want to keep it a fraction. Yeah, it's crazy, but it's true, okay? So why am I showing you how to solve this for y? Let's rewind all the way back up to graph this line. If I gotta do this every time I plug in a variable for x and solve it for y. Plug it in for x. I don't want to do that. So you know what I do one time? I take this equation, I solve it for y, and then I put x right there. And I multiply it by 2 and I subtract 3. Do you see what I mean? So now let's go back to this. If x is negative 1, what's 2 times negative 1? Minus 3. Boom, negative 5. 0 times 2. 0, minus 3. 1 times 2, 2, minus 3. Got it? And let's take this even a step further, that why it's so beneficial to have it. Because if it's solved for y, Ben said this earlier, once I know what that number is, I don't have to do any more calculations. Because I know the rate of change is 2. I'm just going to keep making this go up by 2. And 2 up from 3. And 2 up from -1. Got it? So there are shortcuts galore here. If you take the time to solve it for y, your life will be easier. Okay? So we are solving equations for y, and that's y. Okay? All right, we got one more thing to show you.